All right, so welcome to our webinar on AI and ML in the Microsoft Azure Data Platform. This is going to be an introduction, an overview on how things integrated together inside the platform. My name is Armando Lacerda, so I believe you are seeing both myself and my slide deck. I'll be out of picture in a few. As you can see, I'm in my little studio here in my home office, and I have my green screen behind me. And I always, when I do these webinars, it escapes me that GoToMeeting doesn't support green screen yet. So, or at least I don't know how to do it. Usually do on other platforms. So unfortunately, I will be out of camera for the rest of the webinar. But I just want to introduce myself first before I take this green thing behind us and let you guys focus on the content of this webinar. So again, my name is Armando Lacerda. I work for Wintellect, which is now an Atmosphera company. We joined forces together a couple months ago, and I'm a senior data platform and data architect focused on cloud technologies for Wintellect. Been working with multiple clients of multiple sizes, and we've been approaching data processing, data engineering, data transformation, and machine learning as is the topic for this webinar. I'm also a Microsoft MVP, which it's an award that Microsoft gives to people like you, like me, who like to share what we know, like we're doing here in this webinar for free with the community. And our goal is always to improve the knowledge and the skill set of our colleagues. So I hope this is beneficial to you. I'm also a Microsoft certified trainer, and I'm looking down here because I have a monitor here with the screen sharing. So I'm also a Microsoft certified trainer. I've been training Microsoft. I've been training on Microsoft classes, been teaching Microsoft classes for over 25 years. And it's just something I love to do. I love to be in a classroom, and I love to learn from others' experience and try to help them out with the technology that I know how to deal with. Please feel free to connect with me on the social media. LinkedIn is my preferred channel. Most of my posts go there. Most of my posts go there on LinkedIn. I usually reflect on Twitter, but I don't tweet much as well. And Facebook is more for personal things. So if you're gonna be riding my motorcycle around, or doing scuba diving or surfing, whatever, you're gonna find pictures of that there on Facebook. But LinkedIn is my preferred social media, right? Let me see here. If I can find the mouse. Here's the mouse. There we go. And a little bit about Wintellect. We are a consulting company really focused on the cloud platform. We also work helping people migrate, helping companies migrate from on-premise to the cloud. We work everything Azure, everything cloud-based, application migration, infrastructure migration, database, and data pipelines related consulting. We also do training, both in person and online. Lately, we've been doing a lot of online due to the pandemic. But a couple of weeks ago, I just had my first in-person down there in Dallas after the pandemic, so that was great. And we have the live training, and also we have on-demand training on our Wintellect Now channel with recorded classes where you can follow on your own pace and do the labs on your own pace. We are Microsoft partners, been partners for a very long time. We have received a lot of awards, and you probably have seen some books that my colleagues have written on Microsoft technologies, mostly on the development side of things. So now I'm gonna go out of camera and take this ugly green thing behind me and take it away from your monitor. There we go. And let's go ahead and focus on the content. You'll see during the slide presentation that there will be like a empty spot on the right side of the slide. That's where I should be showing there. That's how I like to present. But again, I apologize because I have not figured out how to do that on the GoToWebinar platform yet. And our agenda for the next 50 minutes or so, it's kind of a short, just 3 points. But what we really be investigating and learning about and diving into is how machine learning, how AI, machine learning, cognitive service, how these things integrate together, what they're all about, and how they integrate with Microsoft Data Platform services. In particular, I'm going to run an example from Synapse, right? You're going to see the integration with Azure Synapse Analytics. So let's get started with an overview and an understanding of AI and ML in the Microsoft platform in Azure. If you go, like these pictures I have taken from, or these designs I have taken from Microsoft's website. If you search for the thing, like architecture reference for Microsoft and AI, you will see we'll see one of the options there is like this particular design here on the screen. And what you see here, the goal of bringing this one here is for you to understand where is AI, where we are, where these designs, and in a way, these designs, they also kind of oversimplify things. And I really need you to start understanding some of the distinctions that happen in here and some of the elements that really don't show up in here. So as you can see, this shows like a pipeline in data flowing from sources. So in this particular case, there are two sources in here. Streaming sources going through event hubs. It could be IoT devices or some other sort of streaming data coming through, and also batch data, right? When files land on a storage account, they are made available in there, so they can also be used for data processing. So this is the beginning of a pipeline, a very traditional pipeline. And in this particular case, for whatever use case this architecture was designed for, they are using Azure Functions to implement some sort of data transformation. Seems to be rather simple, right? Into more scalable environment, scalable use cases, we should use more specific data compute resources, and we'll see in the next design. But in this one here, it's pretty simple. Actually, we just spoke with a customer that has something similar to that not long ago. So the data is transformed from the sources through regular, code, C# code, Python code, or something, and will be stored into a database. What is interesting on this design here that I would like to call your attention to is that the Azure function that is designed in here is taking advantages, leveraging this particular service called Azure Cognitive Services. You can see here on my cursor, right? I'm pointing with my cursor. Azure Cognitive Services. And Azure Cognitive Services is one of the Azure AI options you can use in your implementations. But notice that the cognitive services is being called not by a data service, not by MySQL, for instance. In this case here is MySQL Server Data Platform, not even SQL Server. And so it's not used or being processed from here, right? It's the Azure function that's calling this one. So the first thing to keep in mind when you are doing data processing, in particular when you're doing AI, is when you create a model, and cognitive services are nothing else but pre-trained models in Azure that you can use and pay for. When you use models, you will need compute capacity. The data has to go through your model, and you need CPU to process that data going through your model. So compute in this particular case is down here, right? If you are making notes, cognitive services offer both the pre-trained models, which you can also customize in some aspects. So it offers both the pre-trained models and compute. So offer both things in one service, which is kind of cool. So the Azure function is never overloaded with model processing. It's just making an API call to cognitive service and get the result back. So if it's an image going through, for instance, detecting what is in the image, Azure functions just get the payload back with what has been detected on the particular image and saving that to a database. So a couple of things we have seen so far that I need you to be making note of. And of course, if you want to take screenshots of this slide decks, the slides will be made available, of course. But when I'm in these webinars, I like to take screenshots and make my notes on the screenshots. So just a webinar attendee pro tips for you. Yeah, so this one down here, pre-trained AI models, and in Azure they're called the cognitive services. Well, when the data arrives in the database, in the data store, you see there is another option in here that goes on the side called Azure Machine Learning. So I got machine learning and I got cognitive service, and they both are related to AI. Kind of interesting. And both of them, AI, the whole thing about artificial intelligence is they are nothing else than customized, kind of a synonym term, right? Customized, specialized, or tailored statistical models to a particular use case. So at the end of the day, the bottom line of this thing, AI is all about statistical calculations. There are other areas of AI when we use some other techniques to analyze things, specifically on imaging, for instance, when we use convoluted networks and some other approaches to it. But for the most case, when we look into AI, we are looking into predictions, we are looking into patterns, we are looking into some specific regressions kind of things, and they boil down to statistical models. And both in here on the machine learning service in Azure, in machine learning and cognitive service, what you have in there are those statistical models. The main difference in between these two is that the machine learning is you customizing the model from ground up, right? It's all about you customizing the model from ground up. While in the cognitive service, the models have been already created for you, and you may tweak them here and there where it's allowed, but for the most part, they are already pre-trained and ready for you to use. But if you can recall, every time you use a model, so the model is this statistical model that has been tailored, customized to your particular needs. When you use a model, you do need compute. And machine learning studio, in this case here, or the machine learning service, which we'll be showing on demo in a few, it does provide you an environment for developing your custom models. It does provide you with the capacity for testing and training if you have data available, but it really does not provide you with compute resources for production. Meaning, you create your model is good to go. So when you want to analyze your data, either in streaming or batch style, like this one provides a compute resource, on the machine learning studio, on the machine learning service, you don't have that. You have to get it deployed someplace where it will have the compute capacity associated to it. In this particular design here, like I warned you in the beginning, it's kind of missing that. Where is that compute? It's like, is it kind of it seems to be showing MySQL Server as a way to doing that, a way to process the model, but actually can't. So it's missing, this particular design here is missing that needed resource, which is a compute resource for the model. But the approach is correct, right? The approach is right. If I'm going to create my own models, I need to have Azure Machine Learning going on for me so I can create my models, which I will demo in a few. The next architecture design that I have here that I also got from the architecture reference goes like this. So this one here, it's more into a more, I would say, robust, a more robust data processing pipeline. And as you can see, I collected 2 architecture designs in there for pipeline demonstrations, because most of the times you're doing this either on the fly, on streaming, or in a batch processing. And in this case here, you see that the design points to Databricks as the compute capacity. And Databricks is a very good resource, a very good option in here. It's super scalable, right? It has a high capability, it's highly capable of scaling. So regardless of the amount of data that's coming from the sources, you more likely will not have much problem or no problem at all having Databricks processing your incoming data, especially it's streaming. And as you can see on this one here, they relied, again, like Azure Function was relying on cognitive service before, it's relying on cognitive services again to do the streaming. Now, the next point I want to highlight for you in here is it's really related to scalability and how fast you can get things done for you. Because when you are when you have your AI model and you deploy your AI model outside the computing element, the compute resource that's running here, in this case Databricks, that's running your pipeline, you do have some delay going on here, right? There is a round trip that happens between Databricks and a call to the cognitive service. So cognitive service is actually another service, is a remote service within the Azure infrastructure. So is it within Azure? You never leave Azure, but they are 2 distinct services. And if you're running Databricks and cognitive service in the same region, you're not going to have a bunch of a network delay, but you will have a delay because it's one service calling another service, meaning the compute of the data that's coming here through the pipeline from step number 1 down to the AI is delayed because you're going through the network. Your compute is not really associated with the actual compute doing the pipeline itself. So this works. There is nothing wrong with this pipeline, right, or with this design. What is noticeable here is that every time I depend from outside services, I'm slowing down my pipeline. The best option in here, if I'm looking into performance, is not to call external service, but have the machine learning model that I want to use in the compute element that's processing my pipeline. And here, this is exactly what we'll be doing at the end of this webinar here, at the end of this demonstration. We will have a trained model built into or embedded, like I use in the title of this webinar, embedded into the compute element of the pipeline. In this particular case here, this pipeline refers to Databricks. And in my demo, I will be using Azure Synapse. So we can just see Synapse replacing Databricks on my scenario here, right? On my demo when we get there. So the bottom line so far that I really want you to gather from this first minutes is this. When we talk about AI, AI is a very broad term in the cloud spectrum, right, in the computing spectrum. Depending on the context where you are at or working on, it can mean different things. So very specifically to Azure, to Microsoft platform, when we talk AI, we will be talking one of 2 things. We'll be talking either Azure machine learning, or we will be talking cognitive service. What's the difference between the 2? Machine learning is about you creating your own models and training your own models, while cognitive service is pre-canned, ready to use, at some of the options in there, you do have to do some connections, you do have to do some setting up, but it's not really that convoluted, and you can get that running in a couple hours. But the bottom line is you get ready to market, right? You got your RTM on cognitive services way shorter than we do machine learning. Because when you do machine learning, when you get a team that will work with your particular case, they will spend a lot of time collecting data points, cleaning up the data points, defining the elements in the data points that will help with the statistical calculations, and training the model until it gets to a point when they feel it's really usable, right? Your data science people, your data scientists, they will have to work for a while on your model until it gets ready to use. So this one here, in terms of Azure consumption, it's usually cheaper than cognitive service, usually way cheaper, because you usually pay just for compute when your model is running. But in order to get your model running, you will have to spend a lot of money in your team and in the research of your field. And for some business, this is your goal. This is the way you want to go. If you go into Microsoft website for use case for this, you're going to see awesome examples in there. One that comes to mind is this salmon farm, the fish salmon farm down up north in Europe somewhere. I can remember right now. And the guys, they have to create their models to analyze images and measure the salmons underwater, so they can kind of understand when the salmons are to a point where they can move from place to place in the farms, and when they are ready for harvest. So there were some specific challenges in there. You know, the salmons, they like to swim close to each other on this farm. So sometimes the model has trouble because it seems like it's a big salmon, but it's actually two salmons side by side or very close to each other. So they talk about that on those videos. But again, you have to invest. They had to invest in teams to develop their model because the model was just not available in the market for buy or for rent, right, for subscription. On the other hand, if you go into the cognitive service and the only thing you want to do is like I want to like estimate how the age of someone, want to get a picture, that is something the cognitive service already trained on, and sometimes it does a good guess, sometimes it's kind of off. The other day got me 15 years younger, which I'm kind of glad for that. Thank you. But the bottom line is I didn't have to train the thing, just get the picture and put in there. And if you're looking for like celebrities, it already has a library of celebrity pictures. So most of the people, well-known people, can be recognized by this cognitive service in the image resolution, for instance. And there are so many other applications that are in there, right? So again, bottom line here, machine learning service, cheaper to run, but a lot of investments beforehand, and your time to production can be longer, really longer. It can be really long. Cognitive service, usually a little bit more pricey because it's ready for you to use. Time to execution, time to release your solutions is super short because it's just API calls, and it does support some sort of customization. Sorry, some degree of customization. So let's take a look at that one. Let me grab here my web browser. And I was told that, and if you have questions, please go ahead and put your questions in a question tab. There is a tab or a pod there for you to write questions. I will be reading the questions at the end of the webinar. So if you have any questions, just put in there and I will take a look at them by the end, by the top of the hour, right? When we get close to the end of the webinar. I see one question there already from Samir. I'll get on that later. Okay, Samir, hang in there. So if I go here to the Azure Portal and work with my Wintellect account, we have an account here that Wintellect makes available for us to do this webinar. So we have some credits to use in here. And I created a resource group just for this webinar in here. Here we are. And I'm gonna make this a little larger, fonts a little bigger so you guys can see it better. I hope that helps. All right. And yeah, so I do have a machine learning environment already created here for you, right? So I'll jump there in a second. Before I get in there, let me show you the other one, the cognitive service. Cognitive services. So here in the cognitive service, you have some description about what it does. You see, it has vision, language, search, speech. It does have speech to text, so you can talk to it and it gets that translated to text. And like captioning we have in PowerPoint, for instance, is based on this. And you can embed this in your applications, right? In anything you want to use. So I just go ahead and create this guy on the webinar, and I am in the West US, so I'm using this region here for the examples I'm running. And yeah, so that's my region. The name for this, webinar demo, should be okay. There's only one price tier for these ones. Yep, I sign up for the user agreement. And there is kind of a, this would be enough. Let me go ahead and do this. This kind of be ethical when you do your AI stuff. Make sure you follow best practices and things like that. So you see, having cognitive services this simple, right? Just where you want it to run. There are some specifics on identity if you want to, but just by clicking those simple buttons in there, you have it. And this is my, where is it? Should be here, right? So it's done. Let's go to the resource. Deployment succeeded, should be here. Nope, I do not see it. Let's refresh. It says was created, but I don't see the resource in here. All right, let's go back in here. Home, webinar, this is my machine learning. Well, I'll go back to it when it decides to show up on my resource group. I still don't see it in here. This is my, oh, there we go, cognitive service right now. Perhaps it was already there, I didn't notice. So here is the thing, right? The service we just created, the cognitive service. And this is pretty much what you see from here. There is nothing else because everything on the cognitive service is based on API calls. And there are some tools you can use to do some customizations, like I mentioned, where everything is about API calls. So if you want to get started, like in computer vision, for instance, if I click in here, you will get me to a library of a bunch of examples on how I can do computer vision. And if I think there are some tutorials in here that can help me out. There we go. See, this is an example of a picture. So guessing the age of this young lady here, and some descriptions, some metadata, the payload about that image. And in order to get that going for you, you have, there we go, here are the tutorials where you can see the code that will be leveraging your cognitive service. So just add the elements in here for authentication in your cognitive service and make the API call. And it's that simple, it's that easy, no big deal for the most part. Yeah, so that's one of your options. Your other option, which is the one that I usually get involved with when we're doing pipelines and we have to do custom modeling, is in the machine learning studio, in the machine learning service itself, which is right here. There you go, machine learning. When we get to these services that need you to customize to actually develop your things, you're always going to find this thing called either studio or workspace. And then you may see the name studio here or workspace in here. Regardless, it just means that you're going to get out of the portal and get into a particular environment where people that are not Azure people, but they are specific professionals for the technology, in this case machine learning, to work on. And that's really cool because it splits or creates specific environments where people who are not Azure people don't have to worry about Azure whatsoever. So you see, for this studio here, there is a link. So if I am a project leader and I'm working with Azure, interfacing with the Azure guys to get the environment ready, get things ready, but I also have my team of data scientists and need them to work only on the data science of this project in here, I don't need to grant them permission to go into Azure. I just need to give them this particular link in here, and they can work on machine learning all day long and never worry about Azure whatsoever. So either clicking here or that button over there, doesn't matter. I get into the machine learning studio, and here we are, right? This is where data scientists would be working on. So there are a bunch of options for them to work from here, right? For you to work if it's your case. One example, for instance, is going into the designer. There's a traditional no code or very low code option inside machine learning, where you can design your models, create your models, train your models, and get them ready out for production, right? To be used in production. So for instance, if I want to get this guy here, just to give you an example, I'm going to pick up from the gallery this one that kind of uses regression techniques to do pricing predictions, automobile price predictions. As you can see, this is how it looks like, right? You get a canvas and you get a bunch of resources you can use, like bring data in and select your features from the data that's coming in, do a little sort of a cleanup in here. I'm not really ETL or ELT, right? But you can do some profiling, cleaning up, so you can probe the data. You're a data scientist, so you want to see the data, you want to probe the data, see how the data looks like, and then get to the bottom of the thing, which is, I mean, the core of the thing, which is actually train your model. So this is the model that's been chosen to be used, the linear regression. This step here is getting the entire data and putting some data aside for scoring, for evaluating the model, if it was well trained, if the prediction is to the point where it says sorry, to the point where it hits what the business need. So yeah, so this one here gives like 30% of the data off to this side here and trains the model with 70%, and then see if the model is able to score the 30% left. As you can see, this is the parameters for this particular step in here. So this is the very low code or no code, like in this case here is really no code, where you can create your models. Your models can be really more complex than this one here, but in any case, the models are there. Let's go ahead and submit this model here just for fun. Something went wrong. Let's see. What is it? Select compute target. So I believe I do have an existing one here. I do have this computer target. Remember, every time you need to run a model, you need compute. I did create one. It's not showing there, so I'm going to create one again. Let's go with this predefined here, and this is demo 02. Save this guy. This is going to take a little while to create, so I'm going to save this guy there. We'll come back to this one here and then see this one later. So this is a traditional one. The other one you have is based on notebooks, and I'm going to go to that model here later, right? Our model is here, waiting for the compute to get ready. Computer is not ready yet. Select computer target, demo 02, but still creating. I cannot select that guy yet. So while that one's being created, let me go back in here. This is a more more into the mainstream of machine learning work, which is creating machine learning models and training them using language, right? Use computer programming languages. Most of the times, people love to use Python. Data scientists, they have a lot of libraries they can use in Python. If you go to particular platforms like Databricks, options like Scala also being used in there as programming language. But the bottom line is they will choose a way to write their code and get their machine learning trained, created and trained. In this particular case here, let me take some of the distractions out of the way. In this particular case here, I got another Microsoft tutorial already in place in here to train, create and train a model. I think it's a regression model to try to predict if a particular ride in New York City, a particular ride call would or would not tip the driver. It's a very simple one, but the bottom line here is to understand that you are creating the model and deploying the model. So yeah, so this goes into this notebook and the model I showed you before. They kind of do the same thing. They collect data, they use a data source of some sort, they populate that data source or your data frame, and then work with the data by cleansing and doing massages, whatever it's needed. So I'm not gonna really go into the coding here. I can give you the link later about this one. And at the end of the element here, the end of the processing, all of that, there will be this step here, which is getting the model into a particular format called Onyx Format, which I will go into in a bit. So the bottom line is, in Machine Learning Studio, you have two options to get your model ready for production. One is this one here, which is called low code or no code. And all right, now I can select two. And let's go submit this guy here. Let's go for next, nope, create a new one. So webinar demo 02. And it will be processing there. So I have two models I can choose from once this thing is finished and published. So two options in there to get to your model once it is created, right? All right, so that's the process of creating a model. You have just seen three possible ways, right? What were the three possible ways? You can use cognitive services and just make remote API calls. Cognitive services do allow you, for some of the options in there, to get that Onyx file. We'll be investigating in more details next. But some of the options can be run remote from cognitive service, which means local to your compute, but they have to be online for billing, right? If it's not online for billing, if they fail. Or you can create yours using machine learning, and then you have the two options. You have the designer, the canvas, and you also have the notebooks with your preferred libraries on the environment you want to work with, right? The next step then is get ready to work with that model. So once the model is ready, how do I get the model to work for me? The architectures I have just shown you, they kind of give you an idea of that. But I would like also to illustrate that with this other picture, this other kind of design that I also got from Microsoft. I got everything from Microsoft documentation. So none of these pictures here, I made them myself, right? This is all fully documented over there. I just put it together for you for your benefit. So again, we were here, right? Training the model. We are getting the model ready. My previous demo was about this one here. Once the model is ready, what you do is you register the model. You get once you're okay with the results of your model predictions or whatever the model does, you get that model registered inside machine learning, as you can see here. So then it gets ready to be pushed out. You have a bunch of ways to get these things pushed out. If you can recall, and of course you can use either the editor that's built into machine learning, or you can use your preferred editor to do that. Visual Studio Code is an example, and there are other editors you can use, usually whatever is okay with Python and so on. Once your model is ready, registered and so on, you can push those models out to be executed anywhere where the runtime for your model is available. So one of the options you have, for instance, is creating a website. You could go ahead and create a website and push your model in there. Actually, Machine Learning Studio can help out with that. It can instantiate a web app for you and put all the necessary runtime to run your model from your own web app. Then your web app becomes your compute for your model. Remember, you're not using cognitive servicing here. You are using a machine learning, custom machine learning model that you have created, right? And that's one way of doing it. But again, you're depending on web apps for that. You're exposing a web API for that. What is really in the spotlight nowadays is actually, instead of having a full blown web app just for this thing, like Azure web app just for this thing, you could actually host it as a container, and then you could deploy that container anywhere where containers are supported, including web apps. But if you design your own model and you don't need to be online, for instance, you could have your model in a container running on a drone, for instance, right? Or running on a camera that supports container code deployed to the camera, and have this thing, have your model processed at the edge. So you have, when you go the container side of it, you have a collection of options. You can choose to deploy your model to have your model supported for compute. There are multiple options in there. Like I said, in this case here, we are going away from the actual pipeline processing and we're going more into the compute and close to the data capture of the compute, right? So see, light edge, have edge, you have a lot of elements you can use. Yeah, a lot of options in there. And of course, most of these options would allow you to monitor how they are behaving either at the edge or on a VM or a container or Kubernetes environment in your on-premise environment or in the cloud. Regardless, that's pretty much how it goes, right? You get your machine learning studio being trained with data, and then you get that one deployed someplace, web services, containers, whatever it is, and then used or leveraged, being taken advantage of from any of these running environments in here. So an example of that, let me go back here to my to my studio, right, to the studio in here. If I go back here to the studio, this notebook that I have shown you here before, when it gets to this point here, after it has trained the model with the pipeline, whatever model collects over here and gets the model trained with the pipeline, it generates this file, like I mentioned before, called the Onyx format, which again, we will investigate as we move along. And it gets this model into this particular format and register the model to be made available for deployment pipelines, to get the model published from machine learning so other services can come and pick it up. So if I have like a CI/CD kind of pipeline, I can have a trigger looking into this and coming to here into the machine learning model and collecting my model that I have just trained. And of course, these models can be versioned and tagged, and you can have control of which version is running out. So when this final step in here on my notebook runs, we get this guy here, right? You see the code is, let me go back to the code here just quick. So you see it gets New York City taxi predict, funny example here, predict registered into the available models. So when the model shows up in here, it means, hey, we ran this thing, we export it as a model. Now we want to make, we want people to pick it up from here and move it all the way to production, however it needs to get there to production. That other one we created before, we are still at this experiment level, right? We're still here. See the webinar level 2, the one we created with the canvas. We are into the experiment level yet. And it seems it's still running. I did not create a very powerful compute resource for this guy. So it has stepped through a few elements in here, but not all the way through. It's still working on model training, right? When it gets out, if we're lucky and this thing ends to the before the webinar finishes, we'll see that we will be able to publish this particular trained model, and there will be another option here in my model for publication, right? So this one here, when it exports, this is the in the format we have chosen in the notebook, which is Onyx Format. And what's the deal about this Onyx Format, Armando? Yeah, let's wrap it up with that. The deal with that, we left the presentation right here, right? The deal with that is when you get your model out for production, it needs compute. So it needs to be compatible to the environment where it's going to run. That's the compute is the environment where it's going to run. And depending on the environment, there will be particular formats that will be supported. And Microsoft has made a choice in almost all of their environments, and in particular for data pipelines, to support this particular format in here called Onyx. And you can Google it later. Take a look on the documentation. It's an open format. It's not proprietary, not for a particular vendor. And the deal with the Onyx format is it does have this runtime that reads the metadata in the Onyx file and run that thing, your model. That thing is your model. It runs your model anywhere where the runtime is supported. So you can get Onyx created for you from any of these platforms, right? PyTorch, which is the one we just saw on the notebook, and all of the other ones, machine learning.net from Microsoft, and Cafe, and all of these frameworks in here, and others. There are others that support this. But most importantly, once it's like this, you can deploy it to devices of multiple CPU types. So regular CPUs, GPUs, FPGAs, NPUs. This Onyx runtime is supported in almost in all of this hardware types in here, and a few others. Which means that model I have in my machine learning can be deployed to any of these particular hardwares in here, right? Any of them. More important for this presentation, that particular model can be exported also, or can be brought into Microsoft data environments, and here is where Synapse is going to come in, that also has an Onyx runtime support, and Synapse does have that. So let me go back in here to the portal. Oops, sorry, I just clicked by mistake. Let me go back one. Let me go back here to the portal. So this is my model that's ready there for me. Let's go ahead, and I don't need this guy anymore. Let's go ahead and jump into Synapse. So back here to the portal. Let's go into my resource group, and I will find the Synapse that I have created in here. And Synapse is, in a way, for us here will be our compute environment, but it's where the data is also stored. So this is the benefit of using Onyx with the data platform in the Azure cloud. It's because my model will be executed on a compute that I'm already paying for. So I already have Synapse, and if I have to compute the model outside of Synapse, it's going to be slow, and I'm going to pay extra. It's the worst of both ends. It will be better to bring the model into Synapse because I'm already paying for the Synapse compute, which is also at scale. So it will be way better to have that model in here, and that's exactly what we're going to do. So like the Machine Learning Studio, we do have a Synapse Studio here too. So let's jump into the Synapse Studio. I'm going to browse here just quick on the environment so you can understand what I have already created based on a demo that's available again from Microsoft website. 1 second here, my mouse just disappeared. Yep, my mouse just disappeared. Where are you? All right, sorry for the short silence there, because I'm still looking for my thing. Here it is. All right, so yeah, so I have here my lake. So this is the data lake, and here is some data that was made available for me. You know, very simple data, not that big, right? It's just for you know, to make the case of getting the Onyx model imported. So I have some data here that I want to apply prediction to, right? I want my model to apply prediction to this thing in here. And I already imported this data into my workspace, into my database. So there is a database in here, so called webinar, and I have this table here called New York City taxi, which the data from this CSV file already imported in here. So if I go ahead and select that data just quick for you to see, there we go. See, the data is already there. So there is an information about tips that have been already placed in there. And we're going to see if our model will be able to predict, right, make the right prediction of these tips, right? If and then we can start looking to the future when new streaming data comes in with a ride request, and tell the driver, oh, this guy may give you a tip or not. So we'll see. How to get to my model then? Well, in Synapse, I do have this option here called the management elements, which are the other services in Azure that are integrated with Synapse. And Synapse has multiple data engines. You can see here I have a serverless and a dedicated SQL pool already created there. I created this beforehand for this presentation. And I've also connected to the machine learning environment we're just browsing through, right? That machine learning environment there. And because I have already connected to that, you see if we go here, new, and I will find it here that machine learning is an option in here. So I have been through this process already, and I have connecting there. And because it's there, I can tell Synapse when I go to my tables in here, back to my data, say, notice that this table here, I want to apply some machine learning models to it. I want to run one of my models that I have trained, right? Again, it must be Onyx format. So I get this guy here, I get to choose it, and it's talking to machine learning, found our model that we have made available there. In a more production style, this would have to go through some type of CI/CD deployment and make versioning and approving and testing and all of that. I'm cutting steps in here just to get straight to this. So when I get into here and I see the mappings, because my features and my column names right in the table, right, my features, they kind of match what the model is looking for. And this is the feature where the output will gonna come out. So we got it defined already there. No big deal here for me. If the names were not a match, it would I would have to do the mapping manually. And we do want to get a store procedure to hold the code that will run the model. So I'm gonna got this one here, webinar demo. And I use this name for everything, right? Not very creative, but there we go. Webinar demo, that's going to be my start procedure name. And this goes into the DBO schema. And this table here, the existing table, this table is to carry out, to create the model, where the model will be stored. So that model that's done in machine learning, it will come down here and will live inside Synapse. It will run into the Synapse runtime environment. So DBO my models. And let's go ahead and deploy. This should not take long. Let's just wait a little bit here. Well, there we go, done. So the procedure, the store procedure does a select statement. This is just a wrapper for a select statement to get the data from the actual table where it exists, New York City taxi, and put into a temp table. And of course, I can change this to whatever I want. If I'm working in Synapse and this is a very large table, I should not be using temp tables for this thing. I should be using other tables, create a C-task kind of thing. And once the point is, it's just moving the data to a stage environment. And once it's done in the stage environment, it's running the model There we go. See, running the model. This is the model it wants to run, and this is the version that's been deployed. It was the model. So DBO my models, the table I have created, and using the data from the temp table. You see it in here, and giving me the output. So this particular one here is the one that really executes my model. And actually, if I go here and do select star from dbo.my models, if I run this guy here, you see that there is a model column here, and this is the bits, the binary of my particular model, and this is the schema definition, what are the expected features to run inside this model. So that model you have seen machine learning here in Synapse now. And when I run this thing here, I think I have not created stop procedure yet, so let's run the stop procedure. Stop procedure is running. Let's run this guy again. Execute. So there we go. My output in here is the actual prediction done by my model, right? And if I compare the guy, do I have a scrolling here somewhere? Nah, don't see the scroll, but select start from, yeah, I should have been able to compare this one here with the actual tip that came in. So this is the actual prediction running from my model. Now, what's cool about this thing here that I've mentioned before? The cool about this thing here is my model, I'm not paying extra to run my model. My model is running on a compute that I already have, which is Synapse. It could be the Databricks, for instance. And the other thing about this is there is no network round trip like we have seen in the architecture in the beginning. The data is being processed in the same memory space, in the same compute environment where the model is. So there is no way to beat the performance of this thing. It's really embedded into the data platform. You do have more options besides Synapse to do these things. But another option you have in here, and we ran out of time, so I got to wrap it up here. But another option you have in here is if I'm not changing my model, but I just want to train my model with new data that has arrived in the past 6 months, for instance, I can train the model using Synapse as well. So I don't have to go back to Machine Learning Studio and run a compute in Machine Learning Studio. I can, if the model has not really changed much or not at all, I can just retrain the model using my compute in Synapse, and you do find tutorials to show you how to do that on Microsoft documentation as well. So that's pretty much it, right? You cannot beat the compute and the speed when you do the thing inside the actual data engine running both your data transformation and your machine learning model as well. Just keep in mind, it has to be in Onyx format, right? So that's pretty much all about it on this webinar. Again, my name is Armando Lacerda. I would like to welcome you again to connect with me on the social media and keep the conversation going after we wrap it up here, right? So this is it. We end the webinar here. Now I'm going for the questions and see your questions here on the question pad. So thank you very much for attending the webinar. I hope that was beneficial for you. And yeah, feel free to get in contact if you have further questions. So let's take a look in here. I have one from Samir. Scalability seems to be must-have feature in most systems today. Could you please comment on this related to this simplified architecture, but also in general? Yes. So the thing about cloud computing, Samir, is all about the ability to process more data, right? You need to be able to process, to scale it up, right? For lack of a better term, a different term, to scale it up. Some people would call it scale it out because you do it usually in cluster. And the bottom line is, if you really want to get compute at scale, you must be able to create clusters, compute clusters. If you're not able to create compute clusters, you cannot really scale because you are siloed in one particular hardware capability. And when you do clustering, you do multiple hardware, right? You're using a collection of compute resources. And in order to do scalability, like you mentioned, you need to detach data from compute. And that's where the Microsoft platform really shines. I mean, other platforms do too. Amazon Web Service, AWS, they do have these options there as well. But and you have it immutable. Google Cloud also does support many implementations of that. But the bottom line is, as your company grows, as your company keeps trying to make sense of the data it has acquired over the years and therefore growing, you will need more compute capabilities. And in order to add more compute capabilities, you need to have a design that's able to scale. Most designs for on-premise, they're not made with scalability in mind. If come from SQL Server environment, for instance, for data, could I have this model running on SSIS, which you usually do for data processing on-premise if you are a SQL Server shop? There are ways you can make that happen, but it will not scale because integration service was not designed for scale. It wants to run on a compute host and not in a cluster. So yes, I will go with you. It is a must-have, and the way to get there is by adopting technologies that are able to separate compute and storage. And on the compute side, they're able to create cluster of computing resources. I hope that answered your question. If it doesn't, please keep talking to me on the question pod. Second question from Simon. Can we get a copy of the presentation? Sure. I think I have sent it already. If not, I will send it later to Rachel, who coordinates these webinars, and she will make it available on the website. Is there an Azure subscription plus? Oops, I need to expand this because I cannot read the question. There we go. Is the Azure subscription plus Synapse Studio free to use for community? Nope, it's not free. There is no. You do have a free trial period if you want to check it out. If you want to check it out, you can have a free trial that will give you some dollar credits, not real money, but dollar credits in Azure, and that will be good for a month. Some of the resources will be good for a year anew, but at some point you will have to pay, right? So there is no, you have a period for free trial, but there is no free resource forever in Azure as a whole and Synapse in particular. But there are a lot of discount elements going on in there, so it depends on what you want to do. All right, got it. Thanks. Perfect. Are there any more questions? I see we still have people out there with us here. So are there any more questions? I'm going to give you a couple more minutes to think about your questions. Let's see what pops up here. And as a rule of thumb, always keep that in mind, all right, folks? Try to have your compute close to your data, right? Try to avoid getting your compute too far away from your data. That always creates lag and slowness. Lucia, here are you sending out today's recording? The recording will be made available, definitely. And I don't know how long it takes to get it on the website, but our webinars are made available on the website, sure. Lucia, definitely. Anil, thank you for the presentation, appreciate. Sure, you are welcome. All right, cool. Okay, so I think there are no more questions. I don't see any more questions popping up. If you want to keep the conversation going, once again, just connect with me on LinkedIn and we can talk from there, all right? Have a good, oh, there's one more just popped up in here. Edward. Did the predictive model you should on the last screen had the same data as the original table? No, it can be any data, right? You can, so the question is, do they have to be the same data? No, it was just a very simple example to show the quality of the prediction, right? So we get the data there, we just brought the data in. So when you have the model is available to do a batch processing, Edward, or that batch processing, meaning like we may have a table with 2 terabytes of data and when we're prediction based on the rows that are in there. But tables larger like that, usually you want to do training. But anyways, you can do either one. Or you can connect it to streaming data, data that's arriving on the table, and as the data arrive, you're doing prediction row by row as the data arrive. So no, the model can be applied to any table as long as you can provide the features. In the machine, in AI world, those features are kind of the columns of our tables. So the model requires a particular collection of columns or features, and as long as you can provide a table with those features or a data source with those features, like a streaming data source, you're good to go, right? You can have your output generated. Great question. Thank you very much, Edward. I hope that answered your question. All right. Anybody else? You're welcome, Edward. Anybody else? Once, twice? Okay, folks, enjoy the rest of your day. I hope that presentation was beneficial to you, and I see you in the next webinar. Goodbye.